So last time we tried to create Ethereum smart contracts with low-level tools, and finally we made something where we submitted the data and we got back a contract address. So the code, which represented by this cafe hex, seems to be executed, but unfortunately the execution is failed because the status is 0 for this transaction. But still we are using this local blockchain, which is just running here, and actually it also includes a web UI, so we can check the web UI and we can see all of the transactions. And yes, this seems to be a contract creation, so the code is executed under the hood, but it's failed. But fortunately, the way how this local Ethereum is started, that it's in development mode, so we can get debug information. The only thing what we need is the transaction debug and the transaction hash. Okay, so this is the debug information from the execution. And what we can see here is that the opcode ka from the cafe is not defined. Okay, so what are the opcodes? I would like to use something which is defined, right? Well, if I check the available opcodes, so there is this Ethereum.io where I can find all of the available opcodes. So from 0 to FF, and even not all of them are used. And yeah, the CA is not defined at all, so let's try to use something which is defined. And if we check the available operations, first thing what we can see is that they are very basic, right? Just add, lesser than, greater than, a lot of usual operation. Oh, there is some hashing, which is useful, address, balance, but nothing about network or something reading from file system, because it's a blockchain, right? On each node, the code is supposed to be executed in the same way. The output should be the same way, just to achieve some consensus. So it's very limited. I can push things to the stack, duplicate something on the stack, swap, and a few special thing to create a contract, call something, create, and it's almost the end, right? It's not very much. But let's try something very simple. So let's check, for example, the return. So, right, this is the core of any Hello World application that we need to return with something. Oh, maybe it's easier to search for here. So do we have some return data, signed return data? Oh, this is the return. So this is a stack-based virtual machine which is used, which means that on top of the stack, there should be an offset, and the second item on the stack should be the length of the return. So we have an ephemeral memory here, and from this offset, this length will be returned. Okay, how can I put this number to the stack? Well, that's easy because we had push operations. So push 1 means that just one 8-bit integer can be pushed to the stack, right? This is the result, and you can see that this represents the stack, and the left part is the top of the stack. So let's try to write something like the first assembly, which means that I would like to push 0, 0, and return. So let's go back and check again the return. And the top of the stack should be the offset, which can be 0. And let's say we use 1, and the length can be something. So offset, I would like to put something. Oh, by default the memory is 0, 0. So for example, in this way, this will be the length. So I will return 32 bytes from the memory. Everything is 0 on the memory by default, so we will return with 0, 0, 0, 0, 0. But it looks to be a good application, right? The only problem is that I need to compile it, right? But that's very easy because the return is F3, so that will be the end. And I should check the push as well, the push 1 actually. So push 1 is 60 and the number. So what I need is 60 and pushing the 20. This is the second line, 60, which means that push 1, and I'm pushing the 0, 0, and return. So this is supposed to be a good code. So let's try to submit it. I'm submitting it with a key 1, and the 2 should be null just to execute this code, which is supposed to be a contract creation. I don't need any value because the only thing what I would like to do is execute this one. Oh, and the status is changed, right? The cafe couldn't be executed, but here this code seems to be executed. So let's check, this is the transaction hash. Let's check the debug. And yeah, it seems to be executed. It's not failed. And this is the return code. And this is what we expected, right? Just because it returns a lot of zeros. And let's check what's happened. What we can see here is the execution of all of the lines. And this one is the stack before the execution. So this line put something to the stack, but we couldn't see it because this is the before. After the first line, we see that the 20 is on the stack. So we are just executing the second push, which means that we are pushing this second 0. And after that on the stack, we will have this one and this one. And this is the memory content, but by default it's 0, so it doesn't really matter. And we are just returning the first 32 bytes from the memory from the 0 offset. And yes, it works well. So next time we will improve this one just to add some more logic to see how does it work and get better understanding.